Hello, everybody. In the previous video, we did A part and B part of this problem right here. It's about this function f of x equals x minus 5 in parentheses to the 3 times parentheses x plus 4 parentheses to the 2. So we did A part and B part. Now let's do the C part. Determine the maximum number of turning points on the graph. So let's look at the graph of this function. And here it is right here. It's the red function here. So if we start from the left, it looks like it's rising from the left, and then at -4, it goes down. And then if we zoom out here as far as we can, it looks like it might go down again. It's hard to see. And then it goes up again, and then it stays going up. All right. So it's kind of hard to see from this graph, but mathematically, here's how we can get the answer. So here's what we're going to do. We're going to go to Symbol Lab. And notice that the given function, I'll show the function again. Notice the given function has parentheses in it. And so we want to multiply this out so we can get rid of the parentheses. That will take a long time to do by hand. So let's just use Symbol Lab to do that. All right, so we're going to enter in multiply x minus 5 in parentheses to the 3 times x plus 4 in parentheses to the 2. And then we'll press go. And here it multiplies it for us. Or another thing that we can say did it is expand. Okay, now notice that the degree of this polynomial is 5. So to get the maximum number of turning points is equal to the degree minus 1. So in this case, since the degree is 5, then that's going to be a maximum number of turning points is equal to 5 minus 1, or 4. All right, so the answer is 4 for this one. So let's look at the graph and see if we can verify that. All right, here's the graph. All right, so we rise up, and at -4 it went back down, so that's one turning point. And then at some point it went back up again, so that's going to be it's kind of hard to verify with this graph. All right, so maybe somewhere down here it wiggled a little bit, and then it went back up again. All right, so the answer is going to be a maximum number of 4, but it may not have done it 4 times. Okay, but if it did, it would be up to 4 times. Okay, so that's that one. Now, D part says to determine the end behavior, that is, find the power function that the graph of f resembled for large values of absolute value of x. Okay, that's quite a mouthful. And so here's what it means to do. So whenever the graph goes to the left or to the right, we want to see what happens overall. All right. So to see what happens overall, we want to get the power function, and the power function is going to be this result here, resulting polynomial without the parentheses, but just the leading term, which is x to the 5. Okay, so the power function is x to the 5. All right, so we're going to graph x to the 5. Right here it is. Okay, look at the power function here. Notice that as we go to the left, the y decreases. And in other words, as x decreases, y will also decrease. And if we go to the right, looks like the graph is increasing. So in other words, as x increases, y increases. All right. So all right, so we'll write it like this. As x decreases, that is, as it approaches negative infinity, y is also decreasing, which means y is also approaching to negative infinity. And then as x increases or goes to infinity, looks like y is also going to infinity, which means y is also increasing. All right. Okay, so that's overall what our given function is doing. All right. So let's see if we can look at that more. So with the given red function, it's doing a lot more wiggling than the blue function. But if we go out to the left, it looks like overall the graph is going down. All right. And then as we go to the right, notice that the power function is going, as we go to the right, y also increases, and that's what the red function should do as well. Okay. So the power function gives us an overall view of what's happening as we go either to the left as far as we can or to the right as far as we can. All right, so that's the end behavior. And alternatively, we can even write as x increases, y also increases. And likewise, as x decreases, y also decreases. So that's the overall behavior of our given function, which again was f of x equals x minus 5, parentheses to the 3, times x plus 4 in parentheses to the 2. Okay, so that's how to do the maximum number of turning points and also how to get the end behavior of the given function.